This is Unit 6, Lesson 3 on titration, video number 3. So now we know a little bit about what titration is. Now we're going to look at how it is used. And a very common titration is an acid-base titration. So with all of these, if we have an acid added to a base or vice versa, we end up getting some form of salt plus water. It's a neutralization reaction. So the primary standard that we're going to use in these problems is something called potassium, hydrogen, phthalate. And it is abbreviated KHP, although that is not its chemical formula. Its chemical formula is pretty complex. But it has a formula mass of 204.23 grams per mole and a 1-to-1 ratio to NaOH. So that's our mole ratio. So we're going to look at an example problem. And with these example problems, it's very typical to have the base in the burette and try to find an unknown acid. We could have it the other way around, that's fine. But the reason we have to use a primary standard is because if we use NaOH, NaOH is hygroscopic, which means that it absorbs water from the atmosphere. So even if you let NaOH out in the room, exposed to the atmosphere, in about 30 seconds, it's going to start looking a little bit watery. It almost gets like a shine on it. So it absorbs water very easily. So we can't, if we measure it out, it starts absorbing water and we don't have a true mass of NaOH. So we have to use something like KHP, which is a primary standard, in order to figure out what the exact molarity of NaOH is. So we're going to have two steps to this. So with this, we end up having to standardize a solution. Of NaOH using a given mass of KHP. And we do that through titrating. The second step is we use the standardized NaOH to determine the concentration of an acid. So on this example problem, I'm actually missing something that we're going to write in. So we make a standardized solution of NaOH. We use 2.00 grams of KHP, and this is where I'm going to add this. So this is going to be and is titrated to the endpoint with 125.20 milliliters of the NaOH. That's pretty important. Then we use that standardized solution to titrate a solution of H2SO4 of unknown molarity. 25 milliliter sample of H2SO4 was neutralized with 26.45 milliliters of the standard NaOH solution. So I want to know, what is the molarity of the NaOH, because we standardized that, and then what is the molarity of H2SO4. So with that, we're going to have two steps. Step number one, we're going to use our 2.000 grams of KHP. Notice how many significant figures we have here. We actually have a balance in the classroom that if we get to do a lab, it goes out to 4 decimal points. This one happens to go out to 3. So we know that we have a pretty accurate measurement of KHP. Still not really, really precise, but it is pretty good, 3 decimal places. So we said that the KHP is 204.23 grams of KHP in 1 mole of KHP. And we said that that KHP is going to react with the NaOH in a 1-to-1 mole ratio. So 1 mole of KHP to 1 mole NaOH. So if we stop right there, our grams of KHP and moles of KHP cross out, and we're left with moles of NaOH. We want molarity, which is moles over liters. Well, the whole big solution was 500, but we used 125.20. So 0.12520 liters of NaOH was used to titrate this amount of KHP. So we reached the end point. We would have used phenolphthalein with this, which turns that pink color. So we are going to have 4 significant figures in our answer. So 0.07822 molar NaOH is our answer. So for our second part, we're going to react the NaOH with H2SO4. We typically need an equation in this step. So that's the first thing I'm going to do. NaOH plus H2SO4. So when we do this one, we get water, according to our thing up here. So we get water, and then we get a salt that is made from the first part of the base, Na, and the second part of the acid, SO4. Na is plus 1, SO4 is minus 2, so our formula is Na2SO4. And then we have to balance it by putting a 2 there, and a 2 in front of the water. So, according to this, I have 25 milliliters of this, 26.45 milliliters of NaOH, and I know that this is 0.07822 molar. So I'm going to start with the one that I had the most information. And since we're dealing with molarity and stoichiometry, we have to change the milliliters to liters. So I'm going to start with 0.02645 liters of NaOH. 1 liter of NaOH has 0.07822 moles of NaOH. That's why we calculated this up here. Now we're going to do our mole ratio. 2 moles of NaOH to 1 mole of H2SO4. Now my answer, if I look, is in moles of H2SO4. I want molarity, so I do have a volume here of 25 milliliters. So I'm going to change that into liters, and I'm going to get 0.04138 molar H2SO4. That is my answer for the unknown. Now, titration is used in a lot of lab applications. A lot of food preparation. If you're making something like apple juice, you want to make sure that you have a consistent product. So they take samples off the floor and they can test for acidity. So they would have a standardized solution and they would titrate it to see what the level of acidity would be in a sample, or the percentage of sugar. So titration is used a lot for quality control testing.